Stem and leaf plots. A stem and leaf plot is a quick way to organize and visualize small data sets. Can you determine the largest value, smallest value, and trend for this set of data quickly? A stem and leaf, or stem plot, is a table used to display data. Here on the right we have a stem plot. The stem is on the left of the vertical line, which displays the first digit or digits of the original data value. The leaf is on the right side of the vertical line and displays the last digit of the data value. Here is what the original data looked like, and by having it in a stem plot we can make observations about the data that's not easily detected when the data is in its original form. We can tell where most of the values are falling here in this range, where the highest and the lowest values are well. Stem and leaf plots evolved in the early 1900s and became popular in the 1980s as a quick way to organize data. Here we have a display of the same data, only one is in a stem plot as we saw in the previous slide, and here adjacent to it is the histogram. If we rotate that stem plot 90 degrees, it also has a very similar look to that of the histogram. We can see that the greatest frequency is here in the 40 range. However, the advantage of the stem plot is that it preserves the data. We can see by looking at a stem, for example in the 60 range, that most of these values are on the low end of the 60s. Here, for this range, 60 to 69, in the histogram we have no idea whether they were on the low end of that range or if it was on the high end. So let's create a stem and leaf plot from the data that's shown here. Since our sample data ranges from numbers in the 60s to 100, we will use stem values of 6 to 10, the tens value for the numbers 60 through 100. These numbers 6 through 10 then will form the stems on our stem plot. Next, we will take each of the data values, determine the appropriate stem, and place the ones digit adjacent to it to form the leaf. So our first number is 100. Adjacent to the 10, for the 10 tens, we will place the ones digit or the 0. This is the formation of the beginning of our leaf. The next data value is 65. We will place the ones digit adjacent to the 6 for the 6 in the tens place value. We will continue on with each data value, and the next three here that are highlighted are from the 70s, 80s, 90s, so the ones from each one of those numbers will be placed adjacent to each of those intervals, forming the addition of our leaf. 95, we've already seen one value in the 90, and to place another value in the same range, we just place it adjacent to the last ones digit that we had. Originally we had a 92 with just the 2 adjacent to the 9. We now have a 95 where we will place the 5, the ones digit of 95, adjacent to the 2 that was already there, and continue on until we have completed the stem plot for the given data. There are times when it is useful to order the leaf, though this is not necessary. Order of leaf is required if finding median or quartile values. A key is generally included to indicate the original data values. And here the key in both of these cases, the unordered leaf and the ordered leaf, we have a 6 vertical line 3, indicating that the original form of the number was 63. So, if we were asked these three questions as we started out, where are most of the score values? what is the largest and smallest value with the stem plot, we can answer those much easier than in the original form for the data. Here we have an example of a stem plot indicating class size. The original data is shown here, and we can quickly make observations about the data, the smallest class size being 14, the largest 51, and the 5 zeros in this interval show that there were 5 classes with 40 students in it, which would make up the mode for this data. And also this range of 40 is where most of the class sizes are. So again, quick to create and a good way for a small set of data values to get an indication of the trends for the data.